When you have a polynomial or a quadratic equation that's in standard form and it has three terms, an ax squared term, a bx term, and a c term, a, b, and c are all numbers. A and c cannot be equal to 0, but a would be greater than 1. If it's equal to 1, then you can just use the sum product method. So if your polynomial or your quadratic equations looks like either of these, then you can factor it using the decomposition method. So here we have our polynomial. We have an ax squared, a bx, and a c term. So a, I'm going to write this at the top here, a is equal to 3, b is equal to 11, and c is a positive 6. So you need to be able to identify what a is, what b is, and what c is, because you need that in order to factor this. So this time we're looking for two numbers that multiply to give us a times c. A is 3 and c is 6, so we're looking for two numbers that multiply to give us 18. And when we add those two numbers together, we're going to still get our b value, which is 11. So two numbers that multiply to give us 18, and when we add those numbers together, we get 11. So you're looking for factors of 18. So factors of 18, you can list them out or do them in your head, but that's just 1 and 18, 2 and 9, and 3 and 6. So which pair of these factors will add together to give us 11? And that's 2 and 9. So our special numbers here are 2 and 9. And this time we're going to take those two numbers and use those two numbers to decompose this middle term here. So we're going to start off with writing our first term, 3x squared. And then we're splitting up that middle term, that 11x, into 2x and 9x. And then we keep that plus 6 on the outside. So again, we took our 11x and we decomposed it using our two numbers that we had, 2x and 9x. So 2x plus 9x is just 11x, which is why we're allowed to decompose that. So that's where the word decomposition comes from, because we're breaking up that middle term. So now we're going to do something called factor by grouping. These first two terms here, we want to find a common factor and pull that out, factor out that common factor. So between these first two terms, 3x squared and 2x, the common factor, the greatest common factor between those two terms is x. So when we pull out that x from both terms, we're going to get 3x and 2, well 3x plus 2 in the brackets. And in our last two terms, we're going to group those together and find a common factor between those two terms. We want to pull out that greatest common factor. And between 9x and 6, our greatest common factor is a positive 3. So we're pulling out a positive 3. And in the brackets, we're going to be left with 3x plus 2. 3 times 3x is 9x, and 3 times 2 is 6. So let me just sum that up again here. So we have our first two terms here, and we were looking for a greatest common factor between 3x squared and 2x. And that was just x, so we pulled that out. We factored out that x for those first two terms, and we were just left with 3x plus 2 in the brackets. And then in our last two terms, we were finding a greatest common factor between 9x and 6, and that was just a positive 3. So we factored out that positive 3 from those two terms, and we were left with 3 times 3x plus 2. Now notice something here. Do you see something that's similar between both groups? There's something common, and that's this thing in brackets here, this factor in brackets, 3x plus 2. So we're going to factor out a common factor again. The common factor here is that 3x plus 2. So let's pull that thing out. Let's pull out that whole 3x plus 2. So that's one factor, and what are we left with? Well, we're just left with this x plus 3. So that's our other bracket. That's our other binomial. X plus 3. And there you have it. That is now factored. This expression that's factored is equivalent to this expression right here. You know what? Let's check that really quick. Let's expand that real quick down here. So 3x times x, that's just 3x squared. 3x times 3 is just 9x. 2 times x is just 2x. 2 times 3 is 6. Combine those two middle terms and we're going to get 11x. And we're left with our original expression, 3x squared plus 11x plus 6. And there you have it. This is factored. And let's do another one. So our trinomial is 4x squared minus 8x minus 5. So A is equal to 4, B is negative 8, and C is negative 5. So we're looking for two numbers that multiply together to give us A times C. 8 times C is just 4 times negative 5, so that's negative 20. So we're finding two numbers that multiply to give us negative 20. And when we add those two numbers together, we're going to get negative 8. So we need factors of negative 20. So we got 1 and 20, 2 and 10, 4 and 5. And one of the numbers in these pairs has to be negative, the other has to be positive. So if we have a negative 10 and a positive 2, well, negative 10 plus 2 is negative 8. So those are our two numbers. 2 times negative 10 is negative 20, and 2 minus 10 is negative 8. So we got to use those two numbers and break up that middle term, decompose that middle term. So we're going to get 4x squared plus 2x minus 10x minus 5. And we're taking our first two terms. We're finding greatest common factor and factoring that out. So between those two terms, our greatest common factor here is 2x. So when you pull out the 2x from both terms, in brackets, we're going to get 2x plus 1. And in the second two terms, we need to factor out the greatest common factor. So your greatest common factor between your last two terms is a negative 5. So let's pull out the negative 5. And we're going to be left in the brackets with 2x plus 1. So negative 5 times 2x is negative 10x. Negative 5 times plus 1 is negative 5. So notice how we have the same binomial in these brackets. That's what we want, so we can factor that out. If we had pulled out a positive 5, we wouldn't have the same binomial in this bracket. So be careful. If you factored out the wrong factor, then try it again to make sure you get the same binomial as your first one. So now we can factor out this 2x plus 1. We can pull out this 2x plus 1 in each. So we'll get 2x plus 1 as our first binomial, and then whatever is left, this 2x and this minus 5 is left, that is our second binomial. So 2x minus 5. And there you have it, that is factored. So here's our last question. A is 2, B, well, we just have plus x here, but B is 1. There's an imaginary positive 1 in front of this x. And C is negative 6. So we're looking for factors of A times C, which is just negative 12. Two numbers that multiply to give us negative 12, and when you add those two numbers together, we're looking for 1, a positive 1. So two factors of negative 12, you can list them out if you need to, but I know them already. Our factors of negative 12 are going to be 4 and 3, but one of them is negative, so which one's negative? 4 minus 3 is positive 1, so 3 is negative. So we're using those two terms to break up our middle term. We got to keep this first term 2x squared the same, and 1x just becomes plus 4x minus 3x. And then we keep that minus 6 at the end. So our first two terms here, we need to factor out our greatest common factor, and we're just factoring out a 2x. So when we factor out a 2x, we're going to get x plus 2 in the brackets. And in our last two terms, we need to pull out our greatest common factor, and in this case, our greatest common factor is going to be -3. So in the brackets, we're going to be left with x plus 2. -3 times x is -3x, and -3 times 2 is -6. So in the brackets, do we have the same binomial? Well, yes we do. We have an x plus 2 in each bracket, so we can pull that out. We can factor out that x plus 2. And when we do that, we're just going to be left with this 2x minus 3. So that's our second binomial. And there you have it. We are done. That expression is now factored.